What if tomorrow Jupiter just vanished? It sounds impossible, but what would actually happen to Earth? Let's dive in and find out. Jupiter isn't just a big ball of gas, it's the heavyweight champion of our solar system. With over 300 times Earth's mass, its gravitational pull sculpts the orbits of many bodies, from asteroids in the main belt to distant comets lurking in the outer reaches. Early in solar system history, simulations indicate Jupiter's migration cleared out or destroyed many protoplanets, effectively paving the way for smaller rocky worlds like Earth to emerge in stable orbits. Without that swing-by effect, the inner solar system might have been a chaotic jumble of larger, inhospitable planets. Modern computer simulations, called N-body simulations, which track how objects in space pull on each other, show that Jupiter plays a big role in keeping Earth's orbit steady. Without Jupiter's gravitational pull, key parts of Earth's motion, like how stretched out our orbit is, that's called eccentricity, or how much the planet tilts on its axis, that's axial tilt, could change more dramatically, and those changes affect our climate over long periods. Some scientists still debate exactly how strong this effect is, but most agree Jupiter helps keep Earth's seasons and climate relatively stable over millions of years. Common lore calls Jupiter Earth's celestial shield, deflecting incoming asteroids and long-period comets with its massive gravity, flinging many potential impactors out of the solar system or into benign orbits. But the reality is nuanced. Some simulations suggest Jupiter can also perturb objects, nudging them onto Earth-crossing paths, especially short-period comets or inner asteroid belt fragments. Research at NASA's Jet Propulsion Laboratory indicates that if Jupiter had only a fraction of its current mass, say 20%, Earth would face a much higher impact rate. Conversely, if Jupiter were too massive or in a very different orbit, it might inject even more bodies inward, ramping up collision risks. Thus, Jupiter's specific mass and orbital position seem to strike a delicate balance, providing net protection over eons while still occasionally contributing to impact fluxes that have, paradoxically, driven evolutionary leaps. The dinosaur extinction event approximately 65 million years ago. If Jupiter vanished tomorrow, the gravitational anchor it provides would vanish too. Orbits of asteroids in the main belt could become destabilized. Without Jupiter's periodic perturbations maintaining certain gaps, Kirkwood gaps, and resonance zones, the belt might spread into new configurations, sending more fragments inward over time. Long-period comets from the Oort cloud, currently influenced by Jupiter's gravity when entering the inner solar system, might have different trajectories. Some might pass unperturbed toward inner planets, while others might never be diverted away. Over decades to centuries, we could see a gradual uptick in asteroid and comet encounters. Moreover, perturbations to other planets' orbits would ripple through the solar system. Subtle changes in Mars, Saturn, and beyond could eventually feed back into Earth's orbit and climate stability over millennia. Beyond impacts, Jupiter's disappearance would affect the subtle orbital resonances that help regulate Earth's axial tilt and eccentricity cycles. Without that stabilizing influence, Earth's tilt could wander more widely over geological timescales, leading to extreme shifts in climate, longer, harsher ice ages, or intense warming periods that challenge life's adaptability. While life is remarkably resilient, these changes could stress ecosystems, potentially triggering mass extinctions or altering evolutionary paths. Furthermore, the architecture of the entire solar system could reconfigure. Outer planets like Saturn might migrate slightly inward or outward over eons, possibly destabilizing smaller bodies or satellites. In practical, human-relevant terms, the most immediate hazard is an increased impact threat. Even a modest rise in the frequency of moderate to large asteroid collisions could pose serious risk to civilization, ranging from regional disasters to global downturns if a sufficiently large object strikes. Without Jupiter's moderating gravity, we might need to ramp up asteroid detection, deflection missions, and planetary defense efforts far beyond current levels. Climate instability over millennia, while less immediate, could alter habitability zones on Earth, affecting agriculture and long-term human adaptation. Though such shifts occur on timescales longer than a human lifespan, they shape the baseline environment for future generations. Of course, Jupiter disappearing overnight is pure fiction. No physicist expects gas giants to wink out like a light switch. But this scenario helps us appreciate Jupiter's critical role. By studying how Jupiter influences small bodies and planetary orbits, Scientists refine models of planetary system formation and habitability, insights vital for understanding exoplanets too. Despite the thrilling and chilling premise of Jupiter vanishing, rest assured, Jupiter isn't going anywhere. Its mass and orbital dynamics are stable over billions of years. And even if we consider worst-case asteroid scenarios, our growing capabilities in space observation and planetary defense give us tools to detect and mitigate threats. So tonight, when you gaze at Jupiter through a telescope or catch its glow in the sky, take comfort. Our giant neighbor remains a steadfast guardian and silent sentinel, ensuring we can dream under these stars in peace.